Hi, my name is Eser Tüfekçi. I'm a professor in the Department of Orthodontics at Virginia Commonwealth University School of Dentistry. On behalf of my co-authors, I would like to thank the American Journal of Orthodontics and Dentofacial Orthopedics for allowing us to share the findings of our study, which will be published in the April issue. This is a tremendous honor. As we all know, digital technology is changing rapidly, and orthodontists, the early adopters, are already using intraoral scanning and 3D printing technologies in their offices routinely. With the latest advances in 3D printing and new materials, we hope that clinicians can print clear retainers or even clear aligners directly from an intraoral scan. What if we hit the button on the printer and fabricate the retainer in-house directly from an STL file? Wouldn't it be great? Now, I will turn it over to Dr. Naim, who will summarize the results of his study titled A Comparison of Three-Dimensional Printing Technologies on the Precision, Trueness, and Accuracy of Printed Retainers.
We are very excited to be presenting our introductory research on 3D printed retainers, as we believe that this could become widespread technology in the near future. In our study, we compared the precision, trueness, and accuracy of retainers printed directly from a reference retainer model. We used 4 different printing technologies for the fabrication of our retainers. Stereolithography, or SLA, which uses a UV light source to cure each layer of liquid resin. A digital light processing, or DLP, which uses a light projector to cure each layer. A continuous digital light processing printer, or CDLP, where the build platform moves constantly as each layer is cured. And a polyjet photopolymer, or PPP, where resin is jetted out, similar to an inkjet printer, and cured by a UV light. But a mixture of multiple resins, including soluble resins, can be used. A reference maxillary retainer model in the STL format was used to print 15 models for each printing technology group. Samples in each group were manufactured using resin material, print angulation, and post-processing procedures specific to the manufacturer's recommendations for each printer. Following printing, the intaglio surfaces of the retainers were scanned with the CBCT to create corresponding digital files for each retainer. These STL files were subsequently superimposed on the reference model using previously selected reference points first, and then the best fit method on Geomagic, a 3D analysis software. Precision was evaluated by comparing the retainers within the same group to each other. Trueness, or the closeness of the printed retainer to its true model, was determined by comparing the intaglio surface of the printed retainer to the reference STL file. The root mean square and percentage of points within the tolerance level, INTOL, were calculated for both trueness and precision. A low RMS and a high INTOL percentage indicated a good fit. The combination of trueness and precision was then used to determine the accuracy of the retainers in each group. Results. The 6 previously selected reference points were used to evaluate trueness in the vertical dimension and the intercanine and intermolar widths in the horizontal dimension. The mean difference for each printer type at each landmark was less than 0.25 millimeters, a previously determined tolerance level. The ICW, intercanine width, and intermolar width values were the closest for the PPP printer, indicating almost an identical replication with negligible horizontal shrinkage, while the remaining printers exhibited greater shrinkage. This may be due to the horizontal print orientation for this printer. Previous studies have shown this technology results in the most accurate prints, and a second gel-like soluble resin can be used for supports in this orientation without distorting the main resin. In regards to the precision and trueness, the CDLP and DLP printers showed great precision and a high percentage INTOL and low RMS, but showed low trueness compared to the original retainer. The SLA and PPP expressed high precision and high trueness and were concluded to be more accurate technologies. Limitations. While this study evaluated the overall fit, certain landmarks were shown to have discrepancies reaching almost 1 millimeter, 4 times the accepted threshold. Why a retainer had better fit at one landmark versus another may be due to the print angulation, location of the model on the base plate, post-processing, or overexposure of layers due to the clear resin. The presence of location-specific deviations, more commonly seen in the CDLP and DLP printed retainers, may affect the clinical usefulness of these retainers. Furthermore, these retainers were compared to a digital reference retainer with the supports digitally removed. This may not be possible to do in a clinical setting. However, due to the lack of studies showing how well vacuum form retainers fit once delivered, future studies need to compare a 3D printed retainer to a thermoform retainer, as well as the fit of these retainers on patients clinically. Therefore, future studies evaluating the fit of 3D printer retainers on patients may shed light on the clinical performances of these appliances. Finally, the resins used in our study are not marketed for retainer fabrication. An approved resin material for retainers will need to be used in the future to evaluate the mechanical and physical properties for proper clinical use. Thank you to my co-authors for your guidance and my family for your never-ending support. Back to you, Dr. Tefeci.
The results of our research should be interpreted with caution. In this study, the concepts such as precision, trueness, and accuracy were used to make comparisons between different printing technologies. We concluded that one printer was better in one aspect and another printer was better in another aspect when retainers were printed directly from an STL file. Also, while there were statistically significant differences between printers, there may not be a clinical significance. When this technology is adopted fully, not only the precision and trueness need to be considered, but also the cost and ease of use of the printer. Thank you for watching our video. We hope you will find our article interesting and valuable.